Hi everyone, this is Josh. Last video we covered problem 1 part A, and in this video we're going to cover problem 1 part B, which says compute the difference between the observations on ref and new. Use proc means to compute the following. Since it's given us these commands, it's clear that we're going to be using SAS to do these following steps. So the first thing we're going to do is download batches.sas and paste it into a SAS file. I already have the data set here in my word processing, so I'm going to copy this and paste it into my SAS file. I'm going to use a Jupyter notebook. If you have SAS downloaded on your computer already, the steps are going to be the same. So we're going to paste it in here. If you're not familiar with SAS, I'm going to take a moment now to cover what these lines are saying. First, we have data batches. This is telling SAS the following data set is going to be named batches. So when I run a command, let's say proc print, to print this data set out. Right now there's only one data set, so SAS knows that's the data set I want to print. But suppose there were two. If I had another data set called data test and then said proc print, it would be good practice for me to say data equals batches, for instance. Now SAS knows I want to print the batches data set, not the test data set. Okay, I'm going to go on to the next line now. Input, batch, ref, and new. Input is a keyword that tells SAS the following words are going to be the variable names or the column headings for my data set. So the data set here has the first column, which is 1 through 12, and that's going to be under the column heading batch. The next column are these values, and they're going to have the heading ref, and finally this last column will have the heading new. To see that, I'm going to go ahead and print out this data set, and we need this final line called run that tells SAS, okay, I'm done giving you commands, go ahead and run these commands. And here we have it. We have batch with the first column, ref with the second column, and new with the third column. And just for completeness sake of this last line, data lines tells SAS I'm going to punch in my data set by hand, so everything that follows, all of these numbers are going to be in the data set. And finally, notice that every line ends with the semicolon. If you don't include a semicolon at the end of a line, you're going to get an error. Okay, we're going to go back to the problem and see what we need to do. First thing we need to do is compute the difference between the observations on ref and new. For me, when I first started this, I had already had some familiarity with other programming languages, and I put diff equals ref minus new on this line, and unfortunately this gave me an error. It says the statement is not valid or used out of proper order, and it's referencing this line here. And so SAS works a little bit differently than what I'm used to. I thought ref and new needed to be defined by these columns before I could use them. But SAS works a little differently. Instead, it wants to know everything first, and then it'll read the data set. So now SAS is reading. We have 3 column headings, and then this 4th column heading is going to be the difference between these other two. And now if we run it, we have indeed this 4th column heading, which is the difference between the previous two. And we can calculate this ourselves to see that 44.7 minus 40 is 4.7, which is in fact the value we see here. Okay, that part is done. Let's look at the next part. Use proc means to compute the t-statistic. Okay, well, just as it told us to do, we're going to use proc means. If we just use proc means, notice that it gives us n, which is the number of observations for each column, the mean, standard deviation, and min and max for each column. But it doesn't mention the t-statistic. To get it to tell us the t-statistic, all we need to do is put a space and a t and then run. Now notice that now instead of telling us the mean, the standard deviation, and the min and max, it only gives us the t value. So it has the variable or the column heading and the t-value. If we want to see those other things as well as the t-value, we need to add those behind the means command. So we can put mean, standard deviation, min, and max. And now if we run it, we can see that our columns are back. We have mean, standard deviation, min, and max, as well as the t-value. Since the problem doesn't ask for it, I'm going to remove these extra commands and just have the t-value. The next thing we want to do is calculate the lower and upper 95% confidence limits. This is going to be done similarly. We're just going to put another space and do CLM for confidence limit. When we run this code, it prints out the lower confidence limit and the upper confidence limit. And notice that this is the 95% confidence limit, which is what was asked for. Suppose the problem asked for the 99% confidence limit. How do we do that? Well, we would use another command, alpha, and set this equal to 0.01. And now when we run the code, we see that we have the 99% confidence limit rather than the 95%. But since we want the 95%, I'm going to change this to a 0.05 and run it, and we see it's back to the lower 95% confidence limit again. Now, we don't really need this command since by default it calculates the 95% confidence limit. I'm going to leave it in here just to be explicit and to use as a reference if I forget this command later on. The final thing we need to do for part B is to use either t-inverse or quantile to determine the critical value against which to compare the t-statistic. So back to SAS we go, and I'm going to use an additional data. I'm going to print out an additional data set to do this piece. So I'm going to call it crit. I'm going to do data crit, semicolon. And I'm going to set my variable crit. There's no problem having a data set and a value named the same thing, though it could be a little ambiguous if you get an error that has to do with crit. You won't know whether it's the variable or the data set. And so I'm not worried about that since I've already run this code and have solved all of the errors. So I'm going to set crit equal to t-inverse. Now we need to set the confidence limit, which is going to be 0.975. The confidence limit is 0.05, which means we're going to have two cutoff points, one cutoff point at the top and one cutoff point at the bottom. And the sum of those cutoff points is going to give me 0.05. So each cutoff point individually is going to be 0.025. And 1 minus 0.025 gives me this 0.975. And then for the t-distribution, we need the degrees of freedom. We have 12 observations, and so we're going to have one less for the degrees of freedom to give me 11. Just to show you that it doesn't matter which command you use, that either function works, I'm going to do this crit2 using the quantile command. And the main difference here is we have to tell the quantile function what distribution we're going to be using. I'm going to put a t for the t distribution, and then everything else is going to be the same. Don't forget to end this with a semicolon. And now when we run it, we have down here we have our t value, we have our confidence limit. Oh, and I forgot to print. So SAS calculated all of these things, but it didn't print it out because I didn't tell it to. So now we need proc print, and then we need data equals crit to tell it which data set to print. And now when we run it, we will see our critical t-value here. Okay, now what is this critical t-value? So we're using a 95% confidence interval, and that corresponds to a value of 2.2 on a graph. So the percent refers to the volume covered by the graph, and the value here refers to the x value on the graph that corresponds to that percentage. What's important for us here is that we need these, in particular this t-value needs to be farther away from 0 than the t-value. So if this was -4, that's fine, because it's still the absolute value of this is of -4 is greater than the absolute value of 2.2. What this means is we can reject the null hypothesis. This means that our treatment is doing something. We don't know if it's good or bad, but we do know that it's different from the reference treatment. Okay, that is problem B. Thanks for watching, guys. Join me later, and for the next video, we're going to go over part C.